We have more content that I can fit in 45 minutes, so I may have to go a little bit quick. My name is Joe Conway. I am a committer and one of the major contributors for the Postgres project. Been around the community for over 25 years. I think I started using Postgres in about 1998. I work at Amazon, and I manage the team at Amazon that does Postgres contributions. So all the other committers and major contributors and people that write code and contribute to Postgres that are at Amazon are on my team. Assume if you're here, you already at least have an inkling that there is a problem. Is anyone not aware that there's a problem with collations and glibc versions? Okay, so that's good. I will warn you, you will probably be very scared by the time you walk out of here, because you probably are not fully aware of the extent of the issue. But I will also talk about how you can fix it and an alternative approach that we are using at Amazon, and we open sourced it, and it's available for use by other people if they want to. Okay, so we're going to start out. Hopefully this room isn't that big. You can read this easily. If you do a clean setup on a RHEL 7, how many people here are still running RHEL 7? Anyone? Actually, that's good. All right. If you were running RHEL 7 and you had Postgres on RHEL 7 and you initially set it up kind of per the defaults, this is what it would look like. You would end up with this .col version 2.17. And you can see I'm using this PG database collation actual version. What that function does, it actually queries out to libc and says, what's your version? So .col version is sort of a record of what glibc version was on the system at the time I created this database. But it's not necessarily the same as the version that's on this operating system right now. But when you first set it up, they'll both match, right? And notice that version in 2.17. I'll get back to that later. If you do the same thing on RHEL 9, looks exactly the same except you've got version 2.34. Now again, if you're in this room, you probably are kind of generally aware that there was an issue with glibc version 2.28. Most people think, okay, as long as I don't, kind of avoid that version 2.28 issue, I don't have a problem. The thing is, I'm gonna get to it later in the slide deck. There's a guy named Jeremy Schneider, used to be at Amazon. He was a colleague of mine. He's now left. He's at another company, but he's done some pretty extensive investigations into this. And what he's found is virtually every glibc version changes collation of some character somewhere. So pretty much, if those numbers change, you could definitely have corrupt indexes. Okay, so most people, again, they think, well, yeah, but those changes generally only affect, some strange Unicode emoji that no one's using in my database, right? So I credit this to Jim Legensky, there he is, back there. He's the one that came up with this example, and I call this the in-your-face example. Okay, so these are just ASCII characters, right? If you're on RHEL 7, I'm going to call this a tree shape, all right? And if you're on RHEL 9, you're going to get this other shape, which I'll call a bush, all right? So right off the bat, you can see that very basic characters will sort differently on those two systems. And that, I think, is specific to that glibc 2.28 change, which was very invasive. But still, it's something you need to be cognizant of. It's not just, some strange emoji that someone managed to sneak into your database. It's like really basic stuff that can bite you. Okay, so now I'm going to show you a little bit deeper. If I create a table on my RHEL 7 machine using those same characters, and I get my tree shape when I select with an order by, right? And now I upgrade the OS underneath Postgres to RHEL 9. And what happens? Well, first of all, you notice when I do this select initially, it looks the same. Why is that? We know already it should be different, but it's not. And if you go back one slide here, I created this as a primary key, right? So I shouldn't be able to insert 1A again. But it works. So what happens? Now you say, uh-oh, I remember something about this glibc upgrade thing, and I know I need to reindex all my tables, so I'll just go fix it. You go to reindex and you get an error because now there's a duplicate key violation. So you've got a mess to clean up. So part of the lesson here is if you're going to upgrade your OS, you cannot let anyone into your database to make any changes, at least. Maybe read only, but even read only, they're probably going to get wrong results, but at least they won't corrupt anything. So if we did that query that we did earlier, what we see now is the .col version is still 2.17 because that's what we were created as. But the actual version on the system is 2.34. Okay, so now we got to clean up the mess, right? So it might be done in multiple ways, but one way you can do it is you can look at the CTIDs for these duplicate rows, and I can kind of infer that the 04 is probably the more recent one, and I'm just going to pick that one to delete. And once I've deleted it, I can re-add my primary key because now I don't have a duplicate for primary key. And now if I do this alter database, refresh collation version, what it will do is it will update that .col version. But note, that doesn't actually fix anything. All it really does is changes the record in PG database that now says I'm using a new collation version. So you need to clean up your indexes first. Then do that to make it all look consistent.
Shouldn't you do refresh collation version before primary key again? Add primary key?
It actually doesn't matter. I mean, really, this is just sort of a recording of what the database thinks the collation version was, but it doesn't really affect anything. You're going to get the semantics of whatever the library is. It doesn't matter what that number says. It's just a recording. It's a historical recording in the catalog of what was there. So now if I do my select from that table, I get the bush shape that I would have expected on RHEL 9. And if I look, now that I've refreshed the version, I'm going to see the actual collation version is going to match now. Okay, so now we're going to take it one step deeper. This collation torture test, I mentioned Jeremy earlier. He's got a repository. I provide the link here. So this is Jeremy's GitHub repo. In a nutshell, what it does is he's got enough experience with this that he has figured out what are there's no way to exhaustively test every possible character in every combination with every other character for how they collate, right? But what he knows is what characters typically cause problems. And so he's created this torture test, which is about 26 million strings that are in the 3 to 5 or 6 character long with characters that he knows cause problems, and they're Unicode multi-byte characters, right? And so I created a formatted version of that so I could bulk copy it, and I provide you a link for that if you want to download it. Basically, I just had to go double up all the single quotes so I could cleanly copy it in. So if I copy that into a table, and then this query you see here, you'll see this over and over again. What I'm going to do is select all the strings from the unsorted table and order by those strings, and I'm going to do a string ag over it with no delimiter, which just jams all the strings together in sorted order and then does MD5 on it. So what that does, it gives me like a signature for the table to see whether the sort order has changed for those 26 million strings, right? And you can see, you're not going to memorize this whole number, but focus on this 7E130 because that's the signature of what this set of strings sorted on rel 7 is going to look like. The other thing I want you to note is the time. It's about 3 minutes. Just keep that in the back of your mind right now. Okay, so on rel 7, I can also build an index. If I do that, you notice when I use the index, I get the exact same signature. But now, of course, it's a lot faster. 3 seconds. Now, there's a contrib extension called amcheck, and that has functionality to do checking of your indexes. So this BT index check, I run that across my 2 indexes, and right now you can see it returns null, which basically means the indexes are fine. Okay, so now I do my rel 9 upgrade. You notice that my signature has changed. By now you should not be surprised by that at all. The thing you might find surprising is look at this. 56 minutes. I'm going to go into that a little bit more detail, but I might as well do it now, I guess. It turns out that there is a patch that the glibc maintainers applied to glibc 2.21 in 2014, in which the author of the patch claims it was a performance improvement. He removed some kind of a cache that he thought was like causing performance issues, and he posts some results of some tests that he did in the commit log message that proves that it improves things. Well, somewhere along the line at Amazon, we had people complaining about it. And we discovered what that patch was. But basically, every glibc version, after starting with 2.21, I believe, certainly after that, has this massive performance regression in it. And it's still not fixed. And the last time it was mentioned anywhere I can find on the internet was in 2019 on the glibc. They maintain their source code on like some old site. I forget what it's called, SourceAware or something. And the discussion basically dies out at the end where one of the glibc developers says, well, we don't have anyone who's working on performance stuff for collation, and so this is not likely to get fixed anytime soon. That was in 2019. It's still not fixed. You can check the latest glibc. It'll still perform kind of like this. But anyway, going back to what we were talking about, if I still select, I just did the upgrade and I select by the index, I still see the old signature because I haven't rebuilt the index yet. And so that just should tell you that I'm getting different results. My index is actually corrupt. And if we run our amcheck on it, you'll get an error that'll tell you your index is corrupt. Okay, so this time we were smart enough, we didn't let anyone do any changes to our table. So all we have to do is reindex. So we reindex and we do the select, and now we get the bush that we're expecting, and the amcheck passes the way you would expect. Okay, so that's it for the basic issue that most people are familiar with. Any questions on that before I move on?
Is there a way to remain isolated with this glib version changes?
Any way to what?
Remain isolated from this glib version change and.
Well, that's what I'm going to get to at the end. And that's actually what we've deployed on RDS and Aurora. Okay, so here's a completely different one that most people probably never thought of when it comes to this. Let's say I'm on my rel 9 system, and I'm creating a foreign server, which is pointing back at my old rel 7 system, right? And so I map this table as a foreign table on my RHEL 9 system. The table itself is actually on my RHEL 7 system. And this enables seek scan off. I did that to force a particular plan in order to illustrate the problem. So now when I do a join of my local table to my foreign table on that string column, ordering by the string column, I get this error. And why is that? It's because merge join expects the data on both sides to be sorted so that it can do the merge, right? And you can see here, because of the way I set this up, on the foreign side, it pushes down the order by. That's a performance improvement, right? We push down things. Because that got pushed down, that means the sort on the foreign table happened on the foreign side, which is a different glibc version, and therefore a different order. And so my ordering on both sides don't match, and my merge join fails. So here's another one that you probably haven't thought about. I think Jim was the one who pointed this out too. If you have partitions and you partition by range, right? You know what the syntax is. I'm going to say everything from min value to 1-A is going to go to partition 1, and everything from 1A to max value is going to go to partition 2, right? And those are, I think this is like a less than, and then this is a less than or equal to, or greater than or equal to, right? And so on my RHEL 7 system, when I insert 1A, it's going to go into partition 1. But when I do that on my RHEL 9 system, it goes into partition 2. So talk about a mess you got to clean up. You have partition tables. You have to worry about where your data went, because it may now be in the wrong partition. And I don't have an easy way for you to fix that. I mean, we could sit here and probably figure a reasonable approach, but it's up to you to do that. All right, so just to kind of go through this again, your collation is probably provided by glibc, and here it says Postgres 15 and earlier. It's because in 15 and earlier, you couldn't really even have a database-wide collation that didn't match what you initted the cluster to. You can do that starting in 16. You can use ICU, but the reality is how many people actually change the defaults? And the default is still glibc, even on Postgres 17. So, I venture a guess that 99% or more of the Postgres databases out there in the world probably running with the defaults and therefore are using glibc, and so all this stuff applies. So your sort order relies on the collation, the index is persistent, the constraints may depend on it, merge join and other operations might depend on the order. So all of those things are why you should care about this. And then of course the other thing is, I created this slide a year ago, so at the time these dates had not yet passed, but it's not crazy that people are still running RHEL 7. I know of a system that on the Postgres community infrastructure that's still on RHEL 7. And I'm sure there are people out there still running RHEL 7 for things. Or if they're not running RHEL 7 now, maybe they did an upgrade and actually have some of these issues that need to be fixed. Debian 10, which isn't that old, is already end of life. Ubuntu 14, that's kind of old, but still, those are all end of life. And as I pointed out, even notwithstanding glibc 2.28, every version of glibc has some changes, pretty much. So we have to tackle all these problems, the broken indexes and distributed system problems. So this whole distributed system thing is, as kind of wearing my system architect hat, I would always tell anyone who's designing a system, match everything as close as you can get it, right? And not even knowing why I'm saying it, except it's going to like forestall having problems that you're not going to anticipate. And this is one of the reasons, because when the systems are different, even the different version of the operating system, even different version of the same operating system, it causes differences that can matter. Okay, so there are two kind of solutions to this. One is the forward-looking solution. One is kind of the backward compatible solution that I alluded to a little bit earlier. I don't have that much on the built-in provider, but I'll talk about it a little bit here. The built-in provider was written by one of my colleagues at Amazon, Jeff Davis. Basically about 2 years ago when we started like really getting, I guess it was over 2 years ago now, but we started discussing this problem, and we were talking about, well, how do we fix all the existing releases? And oh, by the way, we should make sure that we really fix this in a better way going forward. But of course, it takes 5 years before all the stable versions time out. So you needed a backward one. You also need the forward one. So Jeff created this forward-looking fix. And what it is, he thought about the way people use collations. And we tend to think of the semantic sorting order as being super important, right? I want EN, US, UTF-8, collation semantics when I do my select order by. But the reality is most of the time when you're using a database, you actually don't care. All you care is that the sorting is done consistently, so that when you're doing a merge or you're doing an indexed lookup, you get the correct result, right? And so the built-in locale, what it does is it bases sort on a binary sort. It's just code point order, essentially. So you don't get the same kind of, you actually get yet a third order here. This is not the same as rel 7 or rel 9. You get a third order out of it because it's sorting based on the binary values. But you can get the order that you want, the semantic order if you need it, by just saying collate. And then it'll use glibc, the local one, and it'll give you the order that you want. And the reality is, if you really need it in that order in the output, you're probably doing it in your application, or you can annotate your query. Now, the reason all this is kind of interesting and important, again, we get a different signature. This is yet a third signature because this is giving you a different order than either of the other two. But look at this timing. 17 seconds. So here we go. This is 17 seconds. ICU and the fast glibc was about 180 seconds. So that's 10x. And then the slow glibc is like another 20x slower, right? So the difference between what you're probably getting by default and what you could be getting with this built-in provider is like 200x, at least for Jeremy's torture test, right? Which is, all right, 26 million strings and their special strings. Your mileage may vary, but the point is that the built-in provider is basically getting you about the same performance that the C locale with SQL ASCII encoding used to get you 20 years ago before everyone started using Unicode. We lost a lot of performance when we started going to everything in Unicode and everything with these fancy collations. And this gets most of that back. And the other big advantage is it's completely under the control of the Postgres developers. It's not coming from the operating system. So, for instance, this could be affected by the Unicode version. But as we started looking at updating Unicode version for Postgres 18, we had a discussion about it. Will that break anything? And we did some analysis, and now we're talking about ways that we can deal with this going forward. When we want to update Unicode version, maybe we need to support two of them at the same time. Those discussions are still going on. They haven't finished. But the difference is with glibc, with ICU, we're completely dependent on someone else to do the right thing. But now with this collation provider, it's up to us.
What is the difference these two?
So this one is using the glibc provider. So you can see it's back to the 53 minutes, and this is the rel 9 string that we got earlier. And the first one is using the built-in collation provider. So this is, if you create your database like this, locale provider built-in locale, c.utf8. So you're basically getting C collation semantics, but UTF-8 character encoding.
Built-in is built-in within database.
Yeah. So this one right here.
Yeah. It won't use the index, but it's
You're telling me that it's not using index, or you're asking me? I think, Jim, do you know, it'll use an index if you build an index with that collation, I think.
Might do separate sort at the end too. That's gonna help.
Yeah, I may have to go test that. It's not something I've done a lot of, but yeah, it's a good question.
So what should be fill factor value for the Postgres creating index?
The fill factor?
Yeah, fill factor ideal value.
I mean, I don't think any of this affects fill factor. I think that the fill factor defaults to like 50% or something. Or is it 80%? I did some experiments with fill factor years ago. I think unless you have a real particular use case, you'll be hard pressed to find, or if you'd like move it to one extreme or the other, you won't see a lot of difference. But in any case, that's sort of has nothing to do with all of this. Because the fill factor just has to do with the way B-tree works. It really has nothing to do with which specific collation ordering we're using.
The result will be the same.
Yeah, I mean, whatever works for one is going to work for the other. I don't know how much. Do I have a time check? 15 minutes? Okay. So I did a pretty good job of speeding up, I guess. All right, so now we're going to talk about my backward-looking solution that I mentioned earlier. Up on GitHub, this is compact collations for glibc. And I'll just show you real quick. I wish I had brought a mouse pad. There's basically two branches here. 2.17-326 and a 2.26-59. And one of them is RHEL. The other one is Amazon Linux 2. And I'll get back to why that's important in a minute. But basically the idea here is I did an analysis of glibc. You know, glibc is basically provides libc, which is the basic library for a Linux system that provides all sorts of services, including malloc and opening and reading files, et cetera, including all the locale stuff. So I went through libc, figured out all the functionality that was related to locales and how to extract that from the source code for libc and build just that as a standalone library. And so the reason to do that is then you can, you know, libc being so big and so pervasive gets all kinds of, you know, security problems. So you have to basically update libc all the time, right? And one of the things I didn't really go into, but is worth mentioning is, yeah, a major version change to libc can change collation. But guess what? Every once in a while, a patch to a given version of libc can cause a collation change. And we have in fact seen that. Jeremy has seen it on ICU. We've seen it on at least one or two times on glibc. So the location, the locale and collation ordering on glibc is not only related to the data files that they use, it's also related to the C code. And in fact, we verified that that performance regression that we were talking about earlier, when you revert that, you get a different sort order. That's how I know this to be true. So what we want to do is tie ourselves to a very specific version of glibc, but we want to do it with as little surface area as possible so we're not exposing ourselves to bugs in other parts of glibc where glibc itself needs to be updated. And so once you've done this successfully, the result, we package it up in an RPM, and that RPM is portable. It doesn't depend on anything else. And so the way you do this is you build on a RHEL 7 machine the compatibility library based on glibc on RHEL 7, and then that RPM can be installed on RHEL 9. And then you build Postgres against that library, and it will use those locale routines, and therefore the glibc 2.17 collation semantics will get used even though you're on a RHEL 9 system. So that's kind of in a nutshell what this thing does. Now, I said you'd build Postgres linked to it. You could also use LD preload to preload the library. I'll go into that in a couple of slides. There's one special thing you got to change if you wanted to replicate all this and you want to preload. And that comes down to version symbols in Linux. Anyone here familiar with version symbols? No. Okay, so the basic idea is when you link a program against a shared library, the library has all these function names, right? And those are symbols. And it's fairly common these days for those symbols to be versioned. So the last time string call was updated on glibc, it might have been, I don't know, glibc whatever, 2.28. And so string call symbol will actually have 2.28 or whatever version it was last updated associated with it. And then when you link your program against that, it says, I'm looking for that version, not just string call, but I'm looking for that version of string call. And when we build this compatibility library by default, it uses its own versions. And the reason for that was so that it'd be easy to inspect and make sure the compatibility library is being used and not the system library. So if you link against the compatibility library, it all works because you just linked using those versions. If you want to use LD preload and actually have it work, you have to build the compatibility library in such a way that it uses the original glibc versions. All right, so this is how you'd create it. You clone this repo, you change into the directory, you check out the appropriate branch. Like I said, right now there's just 2 of them that are supported. There's no reason we couldn't create others. There's just not been a particular need for it so far. Just to give you a sense for it, I originally built this for the Amazon Linux 2.26, and then I ported it to 2.17 for RHEL 7. That effort took me about 2 days. If I were to do it today after not looking at it for 2 years, it would probably take me 2 weeks. If you try and do it on your own without my help, it might take you 2 months. But it can be done. It's not a moon launch, but it's not trivial. Let's leave it at that. Okay, so you just use the build script we provided, and then it'll create an RPM. You do this on the RHEL 7 system. So the way the patch is written, it's on top of a very specific RPM source. So it's built on top of a source RPM, not on top of the glibc source. And the reason for that, when you install a source RPM, you get a structure like this, where you've got this sources directory and a spec directory. The sources directory are all the sources that get used to build the RPM. All right? Now you can see the glibc tar file in there. So that's basically, if you go check out glibc 2.17, you'd get what's in that tarball. But when the RPM is built, it applies all of these patches. Now watch this. This is glibc 2.17-326. There's a fair number of patches. And remember what I said, patches could actually change the sorting semantics. There's 990 files in this directory. I don't know how many of them were patches, but probably 980. All right? So if you want to tie yourself to a specific sort, you really want to do it based on the RPM that you would be using on that system. So that's why it was done this way. The whole idea of the way we made the changes were to minimize in order to manage risk, right? So we didn't want to change anything more than we had to. So there's a few changes to the source code, and then there's some specialized building code to create what we want to create. So the changes fit into kind of 4 categories. glibc had lots of hard-coded assumptions for paths built into it, and what we wanted to be able to do was, remember, if you know anything about locales on Linux, there are these special directories under /usr, and those include data files, and those data files have an effect on how the locale stuff works. And obviously we can't override the system data files, so we have to have a separate directory for our data files. And so we had to fix these hard-coded assumptions. We wanted to make sure that the non-locale functionality could be sourced from the local libc. So we didn't want to be recreating something that we didn't need just for the locale stuff. And there's some really good reasons for that. That's because LD, which is the shared object loader, is actually got structures that it shares with libc. And if you don't do this right, you end up with crashes because of mismatches in those structures. And the symbol versioning that I mentioned before. And then finally, the only real kind of substantive change is that the function that provides the version number out of libc was modified so that it would show not just 2.17, it'll show 2.17-326.el7. So it specifies exactly where this collation is coming from. We had to change the spec file and provide some custom build support in order to build this thing. Okay, so I mentioned earlier, if you want to preload in the build script, there is a variable, enable LD preload. It's set to 0 by default. If you change that to 1 and you run the build, it will build using the original glibc symbol versions so that then you can take this compatibility library and preload it. If you preload the library, then you don't need to link Postgres against it specifically. Of course, then it's up to you to make sure that the library is being found and it's actually being preloaded, and is it actually getting used? You know, so there's a lot of questions you're responsible for if you're going to do that. Okay, so we already talked about the performance regression, but one of the advantages of this is because we pinned ourselves to, in our case, Amazon Linux 2.26-59, which reverted that performance regression. That means we get the 3-minute time, not the 53-minute time. And if you do the same thing with the RHEL 7 version on your RHEL 9 system, you'll get that too. So the bottom line is, you know, this works, and it's widely deployed at Amazon for RDS and Aurora, and it's been deployed now for well over 2 years. I think it first started getting deployed in like December of 2022 or 2023, was it? 2022. Boy, the years go by quick, don't they? So it's been deployed for a while, and it's out there, and it's being used by lots and lots of people, and it's been very successful. Knock on wood. Give me something to knock on. Okay, so this is just what it would look like if you actually use it. You would install the RPM. If you configure Postgres, if you're building it yourself, and you add this libs, like this string right here, and then do a make and make install, then you'll link against the compatibility library. So now, even though I'm on a RHEL 9 system, it doesn't say that here, but I'm on a RHEL 9 system, but I'm using the compatibility library, and I get my tree shape, It's not a broken index. I can't insert a duplicate value. And now, as I mentioned, the actual call version is going to specify exactly where this thing came from. And I could still do my database collation refresh and fix this if I wanted. So again, on RHEL 9 and using the compatibility library, now I'm seeing that RHEL 7 signature, and I'm getting that 3-minute time. And my indexes pass the AM check. Okay, the last 2 slides are just kind of for completeness. If you wanted to play with any of this, this is how I verify that the built Postgres is actually using the compatibility library. And this is a bash script that'll go through and look throughout the build tree at all the binaries and make sure that they've... I can make these slides available. I'm assuming the conference has a place for us to upload slides. If not, I always put them on my own website. Yeah. So all of this, you should be able to just like cut and paste and create something. So that's it. I can always be found, mail@joeconway.com. I've been using that email for like, I don't know, going on 25 or more years. I'm also Conway@amazon.com and Joseph E. Conway on a bunch of the social media platforms.
A question.
Yeah.
Hi Joe, are there any risks to like freezing the glibc at an older version? Maybe, like some newer characters not being supported and that. Like, are there is there anything that can go wrong with like freezing at an older version?
The new character support is really tied to a Unicode version. So you might you'll be using an older Unicode version, but that's actually quite common. I think, Jeremy was telling me Oracle has like 3 different versions of Unicode built into it now or something?
I think it more comes down to, like with government, sometimes you change sort of the individual characters, and you won't get that locked-in version of it. But same thing with like time update, time zone spec. There's different aspects of it, but gives you the consistency. And even if there's new characters added, default to a certain word based on what that binary value is anyway. So it's just a matter of if the government changes sort of the characters, could happen.
But like I said, when it comes for the actual, when the sorter matters to you semantically for human readability or whatever, because of the government rules, you could use ICU in that case, or you could do the sorting in your app and use the sorting that comes with Java or whatever you've got, right, to do the sorting for that final output. So for most use cases where it matters in the database, again, you don't really care what the order is as long as it's consistent.
You have seen similar problem with libicu?
libicu has, Jeremy reports changes in libicu as well. I think they tend to be a little bit more stable than glibc, but not completely. And they have had problems where they've had bugs in given versions, and even within a version they've had changes. And all the same problems that have occurred in glibc, I believe, have occurred in ICU.
And one can create a similar thing for libicu also.
Well, the difference with libicu is libicu is kind of like its own locale library, right? And so it is separate from glibc, and you can maintain an older version. The problem with that is you have to maintain that older version yourself because Red Hat's not doing it for you. And like we've asked Devrim to do that on PGDG Yum repository, and Devrim said, that's too much work, I'm not doing that. So theoretically with ICU, you're not tied to it. You could use the older version as long as you're willing to build it and maintain it and install it on your systems. But someone's got to do that, and right now no one's really doing it.
Even libicu stands at risk. Very few use libicu.
It's better, but it still has issues.
I really like the built-in solution for that.
The built-in solution, 100%, starting with 17, use it. I honestly cannot think of many downsides.
Are there any plans to standardize to that version in in the long term?
Oh, to make that the default?
Yeah, like in the longer
I would guess it will become the default at some point. Postgres community tends to be pretty conservative about making those kinds of changes. I don't think anyone even suggested it for Postgres 18. I could see it maybe happening in 19, but 19 is like a year and a half away. So.
I mean, why depend on the voice? So just get it with the database.
Okay. Well, thank you.